All right, what's good? Let's get to the final exam review. Um, I'll be quite honest, this is the first time I'm looking at it, so let's figure it out together, shall we? Okay, so looking at number one, this is just identifying the types of function, writing the parent equation, and describe the transformation that's happening. So number one, the variable is in the exponent. So this is an exponential function. The parent function will look like, what will it look like? It's going to look like some number, right? 2 to the x. Let's just call it 2 to the x. Y equals 2 to the x. And then describe what's happening. So the circle part, that's the inside part. That's the part that's next to the x. That's the inside lies part. So this is actually going to shift to the right. So it's going to shift right 2 units, and then it's going to shift up 3 units, right? Because of the plus 3. So right 2. Oh, no, not right 2. Right 1. And how we mess up on number 1? It's because I was looking at the 2. So it's going to go right 1. And then up 3. All right. Letter B. The x is being squared, right? So this is going to be a quadratic. And the parent function, y equals x squared. Okay, so there's a couple things happening. So it's going to be inside lies, right? So this green part, this is what's going to shift it to the right. So right 1. Dang it. Did it again. Right 3. So I was looking above it. It's going to go right 3. And then up 1. And then it's going to be a vertical stretch of 2. A dilation, right? But we'll call it a vertical stretch by a factor of 2. Right? Stretch by a factor of 2. All right. Square root of x. So what type of function? What do you call a square root function? Is it just the square root function? It's good enough for me. Let me think real quick. Yeah, square root function. And the parent function looks like y square root of x. Again, inside lies. So we're going to go, this time it's plus 4. So we're going to go left 4. And then down 5. All right, the last one. I mean, feel free to pause and work through it yourself or work ahead. Maybe. All right, so this one's going to be a logarithm. Logarithm. Y equals log x. Base 10 of x, right? There's nothing written. It's base 10. Okay. Again, inside lies. So this is left 1 and up 3. Okay, that's the first part. That's easy. So now getting to number 2. What is a possible polynomial equation based on the graph? Okay. So let's just kind of analyze the graph real quick. So the roots, right? The roots, x equals -3. We have x equals 2. And then x equals 5. All right. So at this root, it crosses. So that means when we turn this into a factor, this is going to be x plus 3, right? Because we're kind of working backwards from the root. This is we consider this to be the bounce. So this means when we turn this into a factor, x minus 2, right, because inside lies, squared because of the bounce. Again, we have a cross. So x minus 5. Okay. A possible equation. There's a value out front, right? There's an a value out front. We need to solve for a. So we need to find a known point, any known point. And here we have the y-intercept. This is going to be when x is 0, y is negative 2. So when x is 0, y is negative 2. So y is negative 2. This is going to be a times 0 plus 3, 0 minus 2 squared, 0 minus 5. Solving for a, we see that negative 2 is equal to a. Negative 2 squared is 4. 4 times 3 times negative 5. 4 times negative 5 is negative 20 times 3, 246. Negative 60. Divide both sides by negative 60. And a is equal to positive 1 over 30, right? Because 2 over 60 reduces. Negative divided by negative is a positive. So a possible polynomial is going to be 1 over 30, x plus 3, x minus 2 squared, x minus 5. This is one possibility. Okay. What if I flip the same graph? Now change the numbers on the x and y axis. So 5 on the x axis is now negative 5. They literally, now what is the possible polynomial equation based on the new graph? Well, the new graph, like, they literally did flip it. Like, the negatives are up top. Okay, so they're wanting me to pretend that the x and y axis is correct. So like negative 5 is to the left, 5 is to the right. Positive numbers are up top. Okay, so, wow. So let's call it x is equal to negative 5. Again, it crosses. X equals negative 2. That's a bounce. X equals 3. That's a cross. So x equals, no, not x equals. X plus 5, x plus 2 squared because of the bounce, and then x minus 3, right, because it's supposed to be positive 3. Can't see it. Okay, then our known point, 0, 2. So when x is 0, y is 2. We're solving for the a value. So this is going to be when y is equal to 2, x is 0, so 5, 0 plus 2 squared, 0 minus 3. So this is going to be, on the right-hand side, we're going to have a. 5 times 2 squared is 4. Negative 60. And then dividing both sides by negative 60. So this is going to be, so a is equal to negative 1/30. So negative 1/30. And then our factors, x plus 5, x plus 2 squared, x minus 3. Okay. All right, so which graph has an x-intercept of 0, 0? So that means when x is 0, y is 0. So let's just see. If x is 0, that's definitely not 0. Right, that's actually negative 4. So, nope. And this is 0, this is 0. That works. We have 0, 0. Okay, that doesn't equal 0. 0, 0. Again, that doesn't equal 0. None, that doesn't even make sense. Well, I guess none would be none of these. So that doesn't make sense because B is correct. Right, 0 over any number is 0. 0 over any number is 0. Any number over 0 is undefined. But in this case, 0 over a number is 0. Okay, number 4, horizontal asymptote. Remember Schrady. Okay, so horizontal asymptote is the E. This is the end behavior. So we have to analyze the degree in the numerator. So there's a square in the numerator. Analyze the degree in the denominator. Again, there's a square. So the largest degree in the numerator over the largest degree in the denominator. And we find out that it's balanced, right? They're exactly the same. So this is where we take the ratio of the coefficients, right? The fraction of the numbers in front. So 6 over 2, which is basically 3. So the horizontal asymptote is going to be y equals 3. Okay, number 5. Y-intercept. This is the Y in the acronym that we teach. Set x equal to 0. So when x is 0, what does y equal? So 0, 0. Y is equal to -5 over -10, which is basically positive 1/2. Right? Negative divided by a negative is a positive. All right. Number 6. Which equation has a vertical asymptote at x equals 3? Okay, so vertical asymptotes happen when the denominator is equal to 0. So when we plug in x equals 3 into the denominator, we get 0. That's our answer. So when I plug in 3, okay, that's not 0. When I plug in 3, again, that's not 0. When I plug in 3, not 0. Plug in 3. 3 minus 3, that is 0. This is our guy. And just for giggles, the last one, plug in 3. Right? Vertical asymptotes happen when the denominator is equal to 0. Since they said x is equal to 3, we know that we teach that the inside lies. So we're actually looking for a x minus 3. And that was it, right? X minus 3. This isn't so bad. Apply the rules of exponents to simplify the following. Okay. Let's do this. So number 7. First thing I see is a 0 exponent. Anything to the 0 power is 1. And we don't care about 1. It just goes away. So all of this actually goes away because of the 0 power. So we have a 2x on top, 3x on bottom. The x's cancel. 2 over 3. Okay. All right, 8. We have 2e to the -5th power, r cubed rather, and everything to the -4th power. So there's a couple different ways of doing this. First off, we don't like negative exponents, and typically you work outside inward, right? Like we would deal with outside the parentheses first, and then do inside the parentheses last. So one way would be to distribute the negative. So then this would be 2 to the -4th power. This would be e to the negative times negative is a positive. 5 times 4 is 20. And then r to the -12, because 3 times -4 is -12. Then, after I distribute the outside exponent, anything with a negative gets changed, either moved to the denominator or moved to the numerator, depending on where we are. This one, everything is in the numerator, right? Because there is no fraction. So everything will move to the bottom. So what I'm saying is e to the 20 is on top. 2 to the 4th, r to the 12th. So 2 to the 4th is really 16, but I'm not too worried about that, right? As long as you know that negative exponents move, right? Negative exponents either move to the denominator or they move to the numerator, depending on where they start out at. Okay, number 9. this exponent has to distribute, not necessarily distribute, but it has to apply, right? It has to apply to everything inside. So this is 5 squared y squared over x squared y 14. I mean, technically we could have canceled out the y's in the beginning, but you know, whatever. Okay, simplifying what I can. Cancel right, 2 y's on top, 14 y's on the bottom. So that's really 12. So 5 squared, which is 25, over x squared, y 12. Let's just write it. 5 squared over x squared, y 12. All right, number 10. Number 10 is just like number 8. So I would definitely apply the exponent to everything inside. So x to the negative 12, y to the positive 6. 2 times 3. Negatives go away. And now anything with a negative will move. Y to the 6, x to the 12. All right. We're cooking. How many pages we got? Oh my goodness. All right, well, we're 1/3 of the way there. All right, this video is brought to you by 7-Eleven. All right, number 11. Another way to write square root of 49. What's it saying? So, okay, 1/2 power. So anytime you have a square root, that's basically a 1/2 exponent. Right? Because, yeah, I'll leave it at that. 12. So this is a cube root. Cube root. So remember, the root is outside. And the root is, right, because roots grow underground. So root is always the bottom number in a fraction. So this is B. It's definitely not that one. Right, because it's a root. 13. Another way to write x plus 3 squared. Right, x plus 3 times x plus 3. So A, right, it's x plus 3 squared. So meaning another one. So x plus 3 times x plus 3. You do not square the x and then square the 3. It does not work that way. Okay. 14. Simplify the following expressions. Okay. So, GCF, right? Top and then bottom. So, top, we can factor out a 4. X minus 1 is left behind. Factor in the bottom. This right here is a difference of squares, right? Because it's a minus, x squared minus a perfect square. So x minus 1, x plus 1. So we got negative 6, x minus 1, x plus 1. Okay, x minus 1s will cancel. 4 and 6, they're both even. So 2 and 3, negative. So final answer is equal to 2 over negative 3 x plus 1. You could move the negative out front if you want, or just leave it on the 3. It doesn't matter. All right, 15. Quadratic divided by a quadratic. So we're going to have to factor 2 numbers that multiply to make 14 that add up to negative 9. 7 and 2. But negative 7, negative 2. Okay. The bottom, 2 numbers that multiply to make negative 14 that add up to negative 5. Again, some variation of 7 and 2. So this is negative 7, positive 2. All right, so top, we have x minus 7, x minus 2. Bottom, x minus 7, x plus 2. All right, we see that cancel, cancel. So final answer, x minus 2, x plus 2. So factor, and then you can cancel out the factors. What you cannot do is cancel like this, right? Because they're locked into the quadratic. You can only cancel when you completely factor first. Okay. 16. Okay, this is going to be slide and divide because there's a 6 in the front. So move it over. So this is going to be 6 times 5 is 30. So two numbers that multiply to make 30, negative 30, that add up to 13. 15 and 2. One's negative, so negative 2. So on the top, we have x plus 15, x minus 2. However, because we slid the 6, we need to divide the 6 and reduce. So this is going to be x plus divided by 3. So 5 over 2. This is x minus 1/3. Okay. We'll just leave it at that. I'll leave it like that. So that's on the numerator. Right, that's on top. Bottom, same idea. 6 times 7, 42, positive, and then 23. Negative 23. So 21 and 2. 21 and 2, but negative 21. So on the bottom, we get, look, I'm going to work a little bit lower. So on the bottom, we have x minus 21, x plus 2. Again, because we multiplied by 6, we have to divide by 6. And then we reduce. So this is going to be, and I'm going to write it up. So this is x minus 7 over 3. This is going to be x plus 1/3. And that's a sneaky one because the x minus 1/3 and x plus 1/3 looks like they would cancel, but they don't. Yo, hold on. So this is minus 2. 21, negative 21 and negative 2 make negative 23. So, dang it. What that mean? That means that this should be a negative and this should be a negative. And now they do cancel. They look like they would because they do. Okay. So our final answer after they cancel. Now, we don't typically leave these as fractions. So if there's a number in the bottom, that number gets moved. So this is 2x plus 5 over 3x minus 7. Final answer. All right, that was 16. 17. Multiply or divide each expression must be in simplest form. Okay. First thing I'm going to do, we could factor everything, but at the end of the day, this division needs to change to multiplication, and we got to flip the second one. So x squared plus 3x all over x squared minus 4. So don't pay attention to that. Okay, so if we factor the top left, two numbers that multiply to make -2 that add up to 1. So this is going to be 2 and -1. Right, 2 and -1. So on top, we have x plus 2, x minus 1. On the bottom, we have two numbers that multiply to make -12 that add up to -1. When they add up to 1, the numbers have to be consecutive. So 3 and 4. 3 and 4 make 12, but 1 has to be negative. So -4, the big one, right? Because it needs to add up to -1. So this is going to be over x plus 3, x minus 4, times on top on the right. So x squared plus 3x. There's a x that's common to both. So you factor out an x. This is x plus 3. On the bottom, x squared minus 4. This is a difference of squares, right? X squared minus a perfect square. This is x minus 4. No. X minus 2, right? Because the square root of 4 is 2. X plus 2. So now we can cancel up, down, and diagonally. Never left to right. So x plus 2, x plus 2. X plus 3, x plus 3. And that's it. So what's left on top? We have x, x minus 1. On the bottom, x minus 4, x minus 2. All right, 18. Same idea, except it's already multiplication. So we don't need to flip anything. We just got to factor and take out the GCF if needed. Okay, so top left, this is not 1. So we have to slide it over. So this is -4, right? Because 2 times -2 is -4. Add up to 3. So two numbers that multiply to make -4 that add up to 3. So 4 and 1. But 1 has to be negative. So -1. Because 4 plus -1 is +3. So on the top, we have... Oh, did I divide that number out? Did that happen on the last one? Oh, no, it didn't. Okay. We have to do that right now. So this is going to be x plus 4, x minus 1. But we have to divide the numbers by 2. So this is going to be x plus 2, right? Because 4 divided by 2. And then this is going to be 2x minus 1 because this number gets to move up. Okay. On the bottom, two numbers that multiply to make -16 that add up to -6. 4 and 4 makes 8. 8 and 2. 8 and 2. 1 has to be negative, so the big one, because they have to add up to -6. So this is going to be x minus 8, x plus 2. I can already see those are going to cancel, but we'll do that in a minute. All right. On the right, two numbers that multiply to make 8 that add up to -9. 8 and 1. But they both have to be negative, right? Because negative times negative is a positive, and you add them up. So we get x minus 8, x minus 1. And on the bottom right, 4x minus 8. This is a GCF situation. Take out a 4, and you're left with x minus 2. X minus 2. Okay. What can we cancel out? So x plus 2, x plus 2. X minus 8, x minus 8. So we're left with, on top, 2x minus 1, x minus 1. On the bottom, 4, x minus 2. Okay. Is that it? That is. All right. Number 19. Add or subtract each expression must be in simplest form. Okay. So the only way to add fractions is to have a common denominator. So the idea is that we got to multiply both sides by something so that the denominators eventually match. Well, the best way to do this is to just try to match what is in the other denominator. So whatever side you're multiplying. So the other side has a 5 and the other side has x squared. Well, the 6x already has an x. So we'll just say 5x. Right? That will make x squared and then it's multiplied by 5. So now top and bottom has to be the same thing. On the left hand side, we're going to multiply the top and bottom by 6. Right? That's it. So if you notice, the denominators are being matched up. 6 times 5 times x times x. 6 times 5, x, 2 x's. Okay, so numerator, we can combine now. So our denominator is going to be 6 times 5, which is 30, x squared. 30x squared. And this is all under whatever 6 times 2 is, or 6 times 12. 12, 24, 36, 48, 60, 72. Plus 5 times 7 is 35x. So we've taken two fractions, combined them into one. And that's as far as we can go. Okay. Number 20. Okay, before we start doing what we did in the last one, it's best if we factor the bottom completely first, because then that'll show us what we need to multiply each side by. So this is the difference of squares, right? X squared minus a perfect square. X minus 5. X plus 5. That's this. So I'll just rewrite it so you can see it. X plus 4 over x minus 5, x plus 5, minus, on the right hand side, we have 15 on top, over. On the bottom, this is a GCF situation, right? Common factor, or greatest common factor. So you could take out a 2 from everything. So this would be a 2 x minus 5. So 2 x minus 5. Okay. We're going to multiply both sides by what the other denominator has that the one denominator doesn't have. So we look at the other denominator. So there's an x minus 5. Oh, cool. There's x minus 5 here also. So not that one. There's a 2. So we need a 2, top and bottom. And that's it. That's all that there is on that side. So then if we switch, go to the other side. Now we got to look at the left denominator. Again, x minus 5 is still there. It also has a 2 now. And the only thing that's missing is the x plus 5. Top and bottom. Okay, I'm going to need some room because to add up the numerators, we're going to have to distribute the 2. So 2x plus 8. Now, this is negative 15, right? Because it's minus. So we could say negative 15. The 15 has to distribute, but then the negative kind of comes along with it. So this is negative 15x, negative whatever 5 times 15 is, 30, 60, 75, all over 2 x minus 5, x plus 5. All right, combining the numerator. 2 minus 15 is negative 13x. 8 minus 75 is going to be negative 67. 2 x minus 5, x plus 5. Feels right. Then again, it feels wrong. Let's rock with it. Okay. Find the value of a if an exponential function of the form y equals a 2x passes through the point 340. Okay, so 340. So this is 3 is your x value, 40 is your y value. So what we're saying is just plug in the values, right? So 40 is equal to a, that's the thing we're looking for, 2 to the x power, which is cubed. So 2 cubed, 2 times 2 is 4, times 2 is 8. So 2 cubed is really 8. So 40 is equal to a times 8. So 8 times what gives me 40? That's what this is saying, right? 8 times what gives me 40? Well, if you don't know, divide both sides by 8, becomes 5. So a is equal to 5. Found the value. Number 22. How much money does Ben need to deposit into his account today in order to have 4,500 saved up? So right now, this is some future amount, right? Because of the way that the language is, right? In order to have, right? That's a future amount, right? That's not what he has right now. 5 years, compounded continuously. That's a buzzword. Continuously. So this is going to be, if I remember correctly, how do we teach it? A pert. A is some future amount. P is some present amount, or the principal amount, times E, that is a calculator function. RT, right? A pert. Rate and then time. So the future amount, this is your A. Right? Future amount is A. So 4,500 equals the principal amount, right? The thing that we would be solving for. We're just setting the problem up. So we're not even solving for it. We're just setting it up correctly. And then E, right? That's a calculator function. The rate, this is going to be, so the rate is 0.0425 because you have to move the decimal place 2 places to the left. So 0.0425. And then time, this is your T, 5 years. So times 5. I mean, that's how you would set it up. Now, the way you would solve it, you'd have to divide both sides by the E to the 0.425 times 5. But it's not asking us to solve it, just to set the problem up. So they're A pert, A-P-E-R-T. E is a calculator function. Future amount, starting amount, rate, and time. So let's just, for your notes, right? This is the rate. Has to be a decimal. T is time. And then A was the future amount. Okay, 23. Again, we're setting it up with the correct formula. So let's see what's it talking about. Matthew received $500 for his 10th birthday. Okay. He deposited it into a savings account that compounds continuously. So this is the same exact formula that we just used. Today is his 21st birthday, and he wants to withdraw the money. How much does he have? Set up the problem only with the correct formula. Okay, so does he want me to answer the question, or does he want me to just set the problem up only? The last one say. How much money? See, because the last one says, how much money does Ben need to deposit? Well, he needs to deposit it a certain amount. We didn't get it because it says set up the problem only with the correct formula. I don't know. Kind of on the fence about these. If it wants me to just set it up only. I mean, it's all calculator work, right? Like you could just literally put the last problem into a calculator. So I feel them on the setup. The setup is the most important part. So A, P, E, R, T. Right? RT is the exponent. A per. And we know it's that because of the word continuously. Right? Continuously. So Matthew received $500. So 500, this is the P. So that's the starting amount. So $500. E, that's the calculator function. R, 2.23. So 0.0223, right? You move the decimal place 2 places to the left. Times T, which would be his 21st birthday today. So how many years have gone by? 11 years, right? 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 11. So times 11 years. And this will equal the amount that he will withdraw today. 24. Christine bought a car for $32,000. The car begins to depreciate the moment she drives off the lot and continues to depreciate at 25% per year. What will Christine's car be worth in 6 years when she pays it off? Okay, so the setup is going to be 32,000, because that's how much we started with. Or here, look, let me give you the formula. Right, so future amount is equal to starting amount 1 minus R, because it's depreciating. And then what variable do we use for the exponent? I don't even know. T, I guess, right? Some sort of time. Okay, so when we set it up, we see that the car will be worth, that's the A amount. So 32,000 times, right? It's depreciating by 25%. So 1 minus 0.25. And for 6 years. All right, there it is. That's the setup. 25. Solve. Okay, so these, when you're solving, X has to equal a number. So what do we do? Okay. We have to, the goal is going to be, if we make these match somehow, some way, and then once they match, we cancel them out in a sense, and the exponents will be equal to one another. Okay, so one's a fraction, one's not a fraction. So what I'm going to do is I'm going to make the fraction not a fraction. So this is going to be 4 right? I can make it not a fraction by making the exponent negative. So you might have to think about that for a little bit. But if you're working backwards, right, think of it like this. So don't even think about this for a second. If I had 4 to the negative x power, okay, we don't like negative exponents. So that means I got to move whatever the exponent is being applied to the bottom, and the negative will actually go away. So then you'd have 1 over 4 to the positive x, and that's what we have up top. Okay, we're getting close, because then this is equal to 2x plus 3. All right, now the goal, because the fraction went away, how do I turn the 4 into a 2? Right, that's the question. Well, I can turn a 4 into a 2 by 2 squared. Negative x is still there. 2x plus 3. Okay, when we have a power that's raised to a power, you multiply. So this is going to be 2 to the negative 2x, 2x plus 3. So right now, the 2's match. So that means I don't care about the 2's. Right? I don't care about them matching. What I care about is that the exponents match now. So negative 2x is equal to x plus 3. One variable problem. Going to minus x. So this is negative 3x is equal to 3. Solving for x. X is equal to negative 1. Okay. All right, number 26. 5 to the 5x is equal to 125 x plus 2. So here, again, if we can somehow make these two numbers match, then we can cancel them out and set the exponents equal to one another. So 125 is actually 5 cubed. All right, 5 times 5 is 25, times 5 is 125, and x plus 2. So 5's match. We have on the left 5x. On the right, we have 3. Again, this has to distribute because a power raised to a power you multiply. X plus 2. So when we distribute, we get 3x plus 6. 5x on the left. This is a one variable problem. Minus 3x. 2x is equal to 6. Divide both sides by 2. X is equal to 3. Final answer. 27. All right, this looks crazy, but I promise it's not as bad as it looks. First thing, let's just start working it. On the left-hand side, we have a power raised to a power. So this is 12x. So 7 to the 12x times 7 to the 6th power is equal to, all right, on the right, the only way to do this on the right is if you know that it's always top minus bottom, right? Top minus bottom. I'm talking about exponents, that is. So this is going to be 7, 2 minus 2x, right? Because the top exponent minus the bottom exponent. Okay. What next? So then on the left, when you multiply common bases, you add the exponents. So then this is going to be 7, 12x plus 6 because you're adding the exponents. On the right, you have 7, 2 minus 2x. So now that the bases match, we set the exponents equal to each other, and it's just a one variable problem. So 12x plus 6 is equal to 2 minus 2x plus 2x, 14x plus 6 equals 2, minus 6 minus 6, it's 2 minus 6. 14x is equal to negative 4. Divide by 14, divide by 14. X is equal to negative 2 over 7. I don't have the key, but that seems right. Negative 2 over 7. I stand by it. Big gulp. All right. Okay. Logarithms. Oh my goodness. Okay. Maybe these go quick. Write the equation in log form. Okay. Let me just write this down up top. So log base b. The argument, we'll call it y equals something. When you rearrange the problem, you can rearrange the problem by taking the base, raising it to this, setting it equal to that. Right. So, raising it to the answer, so b to the x power, is equal to the argument. That's the y. So when you have a log, you can from there do like the little swirl. That's how I remember it. B raised to the x equals y. And then, yeah. So since we know that, we can kind of work backwards. So maybe if we use different colors. So B raised to the green value equals the blue value. So we want this in log form. So log base B. So B is the base. That's the red part. So base 4. X is the green part. So this needs to be out here. X. And it equals the blue part. 10. Okay. I'm going to have to watch that a couple times. 29. So this one is way easier. 3 raised to x equals 5. 3 raised to x equals 5. Too easy. Right. We rewrote it. Okay. Now we're condensing. So all the logs match. So remember, when it's negative, we divide. So both of these are going to go underneath, right? Because we're dividing. So we'll say that log base 7, 42 over log base 7, 3 plus log base 7, 2. Right? The negative log or the minus log just means you divide. Right? So because if this wasn't here, right, if that wasn't here, we would have to move each of these up. Right? So that would be minus log base 7, 2, and then minus log base 7, 3. All right, 31. Okay, so these are slightly different. The 2, right? Remember, the numbers are the powers. That goes up. This goes up. And they're all being multiplied. They're all being multiplied. So log base 3 m times n squared times p to the fourth power, right? All being multiplied. You got to put parentheses to signify that all the three of those things are inside of the argument, right? M times n squared times p to the fourth. And then you would separate them like they were in the starting with the plus, as you're about to see right now in number 32. So expanding number 32 out, this is literally 31 in reverse. So log base 5. So this is 5 times x cubed times y squared. So plus log x cubed plus log, and this is base 5, y squared. So that is the first expansion. All the powers go in front of the log. So final answer, log 5, 5. That's actually a property. I'm not worried about that right now at the moment, though. Log 5x plus 2 log 5y. So the powers go in front, right? If you can get here, I think you're good. But there's this weird property where this is actually going to equal 1 when the base and the argument match. But that doesn't always happen. But when it does, it's a 1, right? If it's a multiple choice, you may not see your answer. And it's because log base 5 of 5 is 1. Now, would they put an answer like this on like the test and, log base 5 of 5, but then count it wrong? I don't think they're that mean. I don't think that would happen. You'll either see log 5, 5 or you'll see 1. I don't think you would see both. Okay. This is number 33, but it's like 30, just in reverse. Okay, so what this is saying, first thing I'm going to do is split it up by the fraction. So log base 5, 3x squared minus log base 5, y. Okay, now this part right here is multiplication. That can actually get broken up. So this is log base 5, 3 plus log base 5 x squared, but the power will come down in front. 2 log base 5 x, right? Because what happened was there was a 2 and it goes in front. I just did it in one move. Minus log base 5 of y. That's a y. So just remember, look, I'll leave it up. X squared comes down. Right. I just didn't want to do another step. Okay. 34. Evaluate each expression. So set the problem equal to x and then you rewrite it. Okay, so understand that this is the argument, right? And this is equal to x. So there's a couple different ways of doing this. I guess the most practical way, 4 raised to the x power is equal to 4 to the 7th power. And this is why we say when the exponents match, or when the base matches, the exponents must match, right? X is equal to 7. 35. Log base 4 is equal to, or log base 4 of 64. This is equal to x. So when you rewrite it, 4 to the x power is equal to 64. So 4 to what power is equal to 64? That's what this is asking. So 4 times 4, 16 times 4, 64. So 3. 4 cubed is equal to 64. So when you're evaluating, set it equal to x. Okay. Solve each equation. Show all your work. All right, rewriting it. 4 cubed, right, 4 to the 3 power, we just said was 64. It equals 2x plus 1. So 4 cubed is really 64. We literally just said that in the last problem. So minus 1. So this is 63. 2x is equal to 63. And then divide both sides by 2. X is equal to 63 halves. I don't understand why it didn't ever just work out like nice, right? Like, why does it have to be like a weird fraction to where we second guess ourselves? Sometimes you gotta trust the math, I guess. 4 times 4 is 16 times 4. Yeah, we literally just said that. 64, it is. Definitely 64. Okay. All right, well, 63 and a half. Or 63 divided by 2. Okay. For number 37. Log base 5, log base 5. Log on each side, that's nice. Right, that means we can just set the arguments equal to one another. So this is 2x minus 7, 3x minus 9, minus 2x minus 2x. Negative 7 is equal to x minus 9, plus 9, plus 9. X is equal to 2. So we believe that x is equal to 2. Well, we need to verify that with logarithms to plug in 2 to see if the argument comes out to a positive number. So let's see, 2 times 2 is 4. 4 minus 7 is negative 3. So that already doesn't work. Now on the other side, 2 times 3 is 6. 6 minus 9 is negative 3. Again, that doesn't work. Okay, so what this is saying, what this tells us, is that there's no solution. Okay, 38. I'm going to condense these down. So this 3 is going to come up. This 4 is going to come up. So this is going to make log base 6, 5, x cubed. Right, because it's a plus, so I can put them together by multiplying. This is going to be equal to log base 6, 5 to the 4th power. So that the logs match. We don't care about those anymore. What I care about is the arguments. So 5 x cubed is equal to 5 to the 4th power. Okay, 5 times 5 is 25, times 5 is 125, times 5, 125 times 5, 625, divided by 5, both sides. So then x cubed is equal to, oh my goodness, we just did this. How many 5s are in 625? My goodness. 120, 125, 125. All right. So now we have x cubed is equal to 125. So what number cubed is 125? Obviously 5, right? We kind of went in circles. 5 times 5 times 5 is 125. X is equal to 5. My goodness. Okay. That was the last of the logarithm problems. It's like we just passed that level. Okay. 39. In behavior of a polynomial. Use your left and right hands. I don't even know what that hint means. I will tell you this. So, okay, maybe I do know what the hint means. when you're looking at end behavior of a polynomial, you look at the leading degree, right? X cubed, up, up, down, 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 up, down. What is it saying? Okay. Hold on. So I get what it's trying to say. First off, X cubed looks like this, right? It starts off down on the left, and then it goes up on the right. Okay, that's X cubed, but it's negative X cubed. Technically, it's negative 5X cubed. I don't care about the number. The negative X cubed is going to flip it. So negative X cubed is actually going to look like this. So it's going to be up and to the left and then down and to the right. That's what it's asking for. This up, down, I don't know. I mean, I feel that's what they're trying to say, right? This is up on the left, right? Up on the left, down on the right. Is it even, odd, neither? So we look at the degrees. Well, X cubed is an odd number. X squared is an even number. So neither. Either they're all one way or they're all the other way. All right, 40 in behavior. So X squared, the leading term, they're either both up or both down. Well, it's negative, so they're both down. Down, down. I guess is what it's trying to say. Even, odd, or neither. Well, if you look, X squared is even, and a constant is treated as an even. We say that it's even. So this is even. We're almost there. 9 more problems. Let's go. Okay, so solve each equation for X. So you work, state the extraneous solutions to each equation. Okay, so extraneous, you may say, what is that? Normally we call this the excluded value. It's what they're saying is what X value makes the bottom 0, basically. So for instance, for 41, right away the extraneous values, as they put it, X equals -1 and X equals 5. If X is either -1 or 5, then the problem is no solution, right? Because it's undefined. It would make the denominator 0. So these are the excluded values. We exclude these numbers from whatever answers we get. Okay, so solving for this, cross multiply and divide. That's probably the best way. So we have 9 x minus 5 is equal to 3 x plus 1. Distribute 9x minus 45. Distribute 3x plus 3 minus 3x minus 3x. 6x minus 45. 3 plus 45. 6x is equal to 48. That's supposed to be a 5, guys. And this is supposed to be a plus. Okay, divide both sides by 6. X is equal to 8. Now, is 8 one of the excluded values? No, it's not. So 8 works. It's the only thing that works, actually. Okay, 42. This is nice. X times x is x squared. 9 times 4 is 36. So square root of both sides. X is equal to plus or minus 6. Right, square root of 36 is 6. So we have 2 answers. negative 6 and 6. The excluded value here would be x is equal to 0, right? That would make 4 over 0. So that's the excluded value. Again, doesn't make a difference right now because the answers are 6 and negative 6. All right, for 43, however, the excluded values are going to be 3, right? Because that's going to turn the left side undefined. And then 0, that would make the right-hand side undefined. Okay, let's see. What can we do here? If we cross multiply, there's a couple different situations, right? Cross multiply and divide. Yeah, let's just keep it simple. So x squared equals negative 4 x minus 3. So x squared is equal to negative 4x plus 12, right? Because I'm distributing. Then we move everything left. X squared plus 4x minus 12 is equal to 0. Right, I just moved everything to the left. And now we factor, right? It's a quadratic. What, two numbers multiplied by negative 12 that add up to 4. 6 and 2. One has to be negative, so the small one. So my factors, x plus 6, x minus 2. And the solutions inside lies. X equals negative 6, x equals 2. We compare to our excluded answers. They don't match. All right, so both of these answers are legit. All right, that was 43. Okay, solve the following cube roots and square roots. Hint, isolate the square root. Okay, so we're trying to get, for 44, we're trying to get this by itself, right? It's a cube root. So isolate the root. So if we're leaving that alone, that means we're going to add 8 to both sides. So 2 cube root, 2x minus 6 is equal to 8. Divide both sides by 2. 8 divided by 2 is 4. Okay, here we say that cube root, okay, so the cube root is isolated. The way that we get it by itself to unlock it, right, is because we want to cube both sides. And that unlocks the 2x minus 6. And 4 cubed. 4 times 4 is 16. 16 times 3. Or no, not 3. 16 times 4, right? Because it's 4 times 4 times 4. So 16 times 4, 64. Said that earlier. All right, plus 6. 2x is equal to 70. Divide both sides by 2. X is equal to 35. All right, just one answer. Okay. 45. Cube both sides because it's already isolated. So this is going to make x plus 1 is equal to 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Minus 1, minus 1. X is equal to 26. Okay. Square root for 46. So I'm going to add 7 to both sides. 7 plus 5. 12. The square root of 2x plus 7 is equal to 12. I have to square both sides because that's how you undo the square root. So 2x plus 7 is equal to 12 times 12, right, 12 squared, 144. Minus 7 minus 7. So 2x is equal to 144 take away 7. 140 take away 3. 137. Divide by 2. Of course it wouldn't work out. Why would it work out? right? 137 over 2. Okay. Oh my goodness. All right. 47, 48, 49. Divide the following polynomials using synthetic division. Remember, degrees must be in order. If not, add a 0. Okay. 3, 2, 1. So all the degrees are there. So synthetic division in the box is -3. Why is it -3? Because it's opposite of that. So we take the coefficients 1, 4, -9, 6. We bring down the 1. We multiply. We write it here. So -3. -3 times 1 is -3. And then you always add going down. So this is add. This is times. Okay. So 4 plus -3 is 1. And then you start the process over. Times -3. Add. So -12 times. This is going to be positive 36. Add 42. Okay. The whole point of this, right, because this was x cubed, this is going to be 1 less. X squared, x. Okay, so x squared plus x minus 12, remainder 42. So we usually say 42 over whatever the divisor was. Kind of wish it just would have been 0. Right, when it's 0, it's nice. Why is always got to be not nice? Let's try it again. But now, just note right here, there's an x squared missing. Right, there's an x squared missing. So we have to account for that. So in the box, we have positive 4. 1, 0, because there's a x squared missing. -7, -2. Okay. Bring down the 1. Times 4 plus 0 times 4 plus -7. 9 times 4, 36. My goodness. This is 34. And the answer, it's always 1 degree less than what you started with. Right? See how there's no symbols here? It's always plus when there's no symbol. So the answer, x squared plus 4x plus 9 plus 34 over the divisor, x minus 4. So what would have been nice is if this would have been 0, and then now we have to factor. I mean, oh, that would have been nice, but I guess that would have been worse. That would have been more work because we're already done. If it's not 0, like, that's it. But if it's 0, you try to keep going if you can. Okay. What do we got here? 3x or x cubed, x squared. All right, there's an x missing. So that means in the box, we're getting -1. Remember, it's the opposite of whatever they give us. So 2, 5 for x squared. 1, no, not 1. 0 because of the x, and then 6. Okay, bring down the 2. Times -1. Plus 5. Times -1. Plus 0. Times -1. So when you add, this makes 9. I'm just double checking my numbers because it's late. Okay, so then this is always 1 degree less. So 2x squared plus 3x minus 3 plus 9 over x plus 1. We can't see it. All right. Hopefully that's it. Hopefully I didn't make any mistakes, any big ones, but you know, if I did, let me know in the comments. All right, good luck. Catch you guys in the next video.